Hi guys, today we'll make a NOT gate using transistor. So let's see the diagram. This is input, this is base resistor, this is collector resistor, this is BC547 transistor, this is voltmeter, this is VCC, this is ground. So here I have given 0 at input and the output is 5 volts. Now I will give 5 volts to the input. You can see 1, okay. So if I give 5 volt at input, the output is 0.1 volt, which is low. So when the output is high, when the input is high, the output is low. When the input is low, then the output will be high. You can see. So this is actually a NOT gate. So let's make it. Okay, so we need two resistors, one a base resistor and another a collector resistor, and we need one ground, so we'll put it here, and then we need a transistor. Okay, so this is BC547 transistor, so we put here BC547. Okay, and we also need the source voltage. Here we take the switchable source which can switch between 1 and 0. Okay, and here we give 1. Okay, and we also need a voltmeter to measure the output voltage. So this is voltmeter, and we now connect these two terminals. Okay, now we have to find out the appropriate values of these two resistors. So here this is the base terminal. Okay, and the base current is in microamperes range. So for this case we take the base current as 50 microampere. So now we have to take KVL in the base emitter loop. Okay, so in this loop, okay, this, okay, and here, so here 5 volts minus base current into resistor R1 minus 0.7 equals 0 volt. Okay, this is the simple KVL. 5 volt minus base current into resistor R1 minus 0.7 equals 0 volt. So 5 minus 0.7 means 4.3 volt. Okay, so now 5 minus 4.3 is equal to 5 minus 0.7 equal to 4.3 volt minus base current into R1 equals 0 volt. So here we take the KVL. Okay, so the voltage is, okay, so we have to calculate the resistance. Okay, so the voltage is 4.3 volt. Okay, and the current is 50 microampere. So you can see the resistance is 86 kilo ohm. Okay, so here we change it to 86 kilo ohm. Okay, and then here you can see if the 5 volt is given here and the base resistance is 86 kilo ohm, then the 50 microamperes current will flow through base. Let's check it. You can see air is 40. Okay, here air is 40 and upper is 50. Okay, and here you can see 50 microampere. Okay, so now here is 1 volt and here should be 0 volt. So here should be 0 volt means that the transistor is in saturation region. The saturation region means that the voltage between the collector and emitter is 0 volts. Okay, so if the voltage between the collector and emitter must be 0 volt, then all the source voltage, all the supply voltage must be dropped in this resistor. Okay, this is collector resistor, so the current through the collector is beta times the base current. Here the beta of the transistor is 100. Okay, you can see here, and hence the collector current is 50 microampere times 50 microampere times 100. Okay, which means 0.005 ampere. Okay, so now here the current through this resistor is 0.005 because this is collector resistor and the collector current is 50 microampere times beta, which is 100. It means 50 microampere into 100, which is 0.005 0.005 what 0.005 ampere. When the current through the collector is 0.005 ampere, then the transistor must be into saturation. It means the voltage between the collector and emitter is 0, so all the voltage must be dropped in this resistor when the current is 0.005 and the supply is 5. Okay, so let's calculate the resistor. So the supply voltage, we have to calculate the resistor. The supply voltage is 5 volts and the current is collector current is 0.005, which is 1 kilo ohm. Okay, so here it is already 1 kilo ohm, so it has given the correct result here. You can see the input is currently 1 and the output is 0. Now if I give 0 input, then the output is 5 volts. Okay, so why the 5 volt occurs at output when 0 is given here? So let's understand it. When the 0 is given here, the transistor is in off state because it needs 0.7 volt to turn the transistor on. Okay, so here we have given only 0 volt, not 0.7. Okay, so the transistor is in off state. So when the transistor is in off state, the resistance between the collector and emitter terminal is very high. Okay, so here is 1 kilo ohm and here is in the range of 1 mega ohm. So all the supply voltage will be dropped in the higher resistance. Okay, this is equivalent to this figure. Okay, let's see here. This is one resistor, this is another resistor, and here switchable source. Okay, and here one voltmeter. Okay, so I'll keep the voltmeter here, I'll give the switchable source here, and here is this, so I ground it. So you can see here now, this is the, suppose this is the collector resistor in this figure and this is the equivalent transistor. Okay, when the transistor is in off, okay, so this is resistor, and when the transistor is off, its resistance is very high in the mega ohm range, so we give here 1 mega ohm. Okay, so now let's see. You can see here is 5 volts and all the 5 volt appears across this 1 mega ohm resistor. You can see similar happens here. When the transistor is in off state, all the voltage supply voltage will appear across the collector emitter terminal of the transistor. But when the input is given high, then the base current will flow. Okay, and when the base current flows, we have maintained the resistor in such a way that all the voltage across the all the supply voltage will be dropped across this resistor, and no any voltage will be seen in the collector and emitter terminal. So here all the voltage drops across this resistor, which means 5 volt is dropped across this this resistor, and only 0.1 volt is coming here. Okay, so when the transistor saturate, the collector and emitter terminals act like sorted. Okay, so